First of all, I'm Matt King. I'm the Chief Technology Officer and co-founder of IUNU, and I want to thank Jeff and his team for inviting us here. I'm one of those mystical systems providers, actually sell services based on computer vision to greenhouse operators using tools and technologies that you build. And the joke has been going around a bit. We are Big Brother, but only for plants. No privacy for plants. We want to know everything there is to know about the plants. We actually don't really do much in terms of watching people in the space. We do a very little bit in terms of watching how long certain tasks take, but we're really just looking at how long motion was happening during a certain time in terms of that. But if you peel back the covers and get down to the business model, what is it that we're doing? We're automating data collection. I'll get into it a little bit further in the presentation as to what the current state of data collection is in this industry, but that's what we're trying to do. We're trying to give them data that they already know they want and data they can't get otherwise. But that's just what we do. What we're actually giving our customers is time. We save them time. Automation is all about that. And people ask me all the time, so you're coming and taking the growers' jobs? Well, no. What we're coming and doing is taking the grower's clipboard. Our robots just replace the clipboard, not the grower. If you look at the statistics nationwide and worldwide, we are flatline on producing growers as a society, as a planet. We don't have more growers than we did 10 years ago. We have the same amount of growers. We have more people who need more food. So if we all want to keep eating, we have to give the growers better tools, and that's what we do. So this is not growing a couple of roses in your backyard. We're talking about commercial, large-scale operations. If you're trying to manage something like this, looking at it manually is just not an efficient way to collect data. And the question is, how big is it? This is one operation, 15 million square feet. It happens to be the largest building in North America. But if you get outside of North America, that's 25 miles across. That's 3 billion square feet of greenhouse in one tiny little spot in Spain. And how do they collect data? This is how they do it. This is how everybody does it. Now, this guy's not actually in a greenhouse. Didn't have that good picture. But that's our competition. The clipboard and the feet. Again, we're not trying to replace the actual eyeballs and the judgment of the grower. That's taken 20 years to develop. What we're trying to do is make it so he doesn't have to go walk around and do everything. We're trying to tell him, where does he not look? Because if you think about that, if you're growing 25 million rose bushes, we have a customer who does. They have a staff of PhDs, many PhDs. When a rose is sick, they don't have any trouble diagnosing what that disease is. But the real question, the economic question for them is, which 24,900,999 roses don't need a PhD to go walk to it and look at it today? So if we can identify for them what's healthy, they can then focus their time where they need to. There's a saying in the grower's world that the best fertilizer is the grower's shadow. In other words, the attention from that grower. And what we're doing is telling them where they should apply that attention. So, same story here. If you're trying to grow a rose bush out back, go back and look at your rose bush. That's called gardening, and that really is a leisure activity. On the other hand, if you're trying to do a commercial activity, you have to do things very, very differently. Greenhouse manufacturing, it is a manufacturing. They are trying to make widgets. Their widgets just happen to be green and change shape and color and size constantly. But consistency is the goal. And in manufacturing, consistency comes from starting with consistency. This is one set of plants that came off the same production line. These are very early, about to start a 3-month grow cycle. They're all going to absorb the same amount of labor, the same amount of water, the same amount of fertilizer, the same amount of pesticides, the same amount of cost. But guess what? The plants on the left will never be sellable. They will never reach the spec that the purchaser wants. but they won't know that for 3 months. So catching that early, which in this case is simple belt, conveyor belt instrumentation with a quality control check, saves them a lot of money. This is also about the concept that right now, they think of these greenhouses as a black box. Some inputs go in, some time passes, and something comes out the other end. No other manufacturing industry anywhere that I've ever heard of operates that way, but yet they do it every day and on razor thin margins. What we do is come in and measure it. For the first time, we can give a grower a real-time growth rate of his plant. If we talked about this in terms of medical terms, that's saying I can give you a heartbeat. The doctor is going to need a lot more information, but if he doesn't know your heartbeat, he just looks at you, and then 3 weeks later looks at you again, how good is his diagnosis going to be? In terms of process engineering, the amount of growth that happens over a time period is how much they have produced. Measuring that is measuring what their business does, and what is measured can then be improved. So we actually turn the growing art into an industrial process that's tunable. This concept came out of this little company called Boeing, who almost 30 years ago decided to reinvent manufacturing again. They've done it a couple of times. And what they decided to do was start taking a picture of every widget at the beginning and the end of every manufacturing step and keeping that record, that visual record. Now, this was pre-computer vision of the way we think about it, and they weren't analyzing this with computers, they were just keeping it with computers for human analysis. But that allowed them to instrument their production process and start changing it. This was a big piece of the lean manufacturing concept. We're doing the same thing for plants. We just, in general, we will change this depending on the plant, the species, and what's going on, but in general, we come through and image and 3D reconstruct a model of every single plant every hour for millions and millions of plants and turn that into unique data for every individual plant. What is Luna? Luna is our product. It's really a service. It's data as a service. Greenhouse growers do not want to be in the IT business. Greenhouse growers do not want to be in the data collection business. So we do it. It's a monthly subscription or a per plant pricing. I'll touch back on that in a minute. Fully managed and supported. We own the gear. We don't rent them gear. We don't sell them gear. They don't have to take care of it. They don't have to maintain it. We do that. It's all included. We also, as a sales tactic, we don't charge anything up front. If we have to come in and talk to them about coming up with a fairly large chunk of change, if that's in their capital budget, there's a cycle time. There's going to be a delay. If we come in and say, nope, we got it, we have equipment financing partners, we take care of that, it's all rolled in, it's a seamless sale. But then we get to the participatory pricing model, is what the VCs like to call this, where we take the whole thing, and this is just now at that point financing, we roll it up and say, you only pay us when a plant sells. So the way that turns around is that you've got a plant that starts in germination, moves to a young plants area, then moves to a finishing house, may move through 4 greenhouses before it hits shipping and then leaves. And we tell you, we provide you a full video, full analysis record of that plant at every minute, well, not every minute, every few hours, as it goes through the process for a certain number of cents. And we keep knocking that number down lower and lower. And you think about that, that's video at plant time scale, and by the way, plants don't need 30 frames a second to be video. But it is a video record of every single individual plant, an analysis of its growth rate, analysis of its health for months, for a penny, for a couple of pennies. And that model really works, because now, not only is it a value proposition, they only pay when they sell something. Sets our goals are to give them the information so they don't scrap it. In other words, they don't throw it away. We want to get it out the door. But it also, of course, ties their payment to us to their revenue, to their income, and makes things simple. What do we use? The one piece of hardware that we've had to build, from everyone else in the industry's point of view, they call it our camera. It's not our camera. We built the system that moves the camera. That's a standard camera mount. We use Basler, we use IDS, we use IUNUs, everybody you've heard of. We put all sorts of sensors on it. But functionally, this is a tethered drone. There's a charging station. It is wireless. It is completely autonomous. It's just fixed and not flying around. We also use what you would all recognize as fairly standard security cam setups. So these cameras are getting the plants. They go through and image and model a plant every hour, whereas the wider angle security cams are running at 30 or sometimes 20 frames a second and watching the whole area. And this is where we do motion analysis of labor, motion analysis of other robots. So they are very fond of big robotic watering boom systems. You've seen these. And they want to know how often those things don't go when they're supposed to, because they have no information about it. And they have cases where something will break and it will be 2 weeks before they find out that that watering boom has not been watering anything. And how did they find out? The plants died. But there's nobody happened to be standing there, and you have millions of square feet to look at. You missed it. What we're doing currently right now. So center of our world is floriculture. This is everything that you find in Lowe's and Home Depot and in your local garden center. These guys are typically 100 to 200,000 square feet greenhouse operations. We specifically cover germination for them. If you go to Ball Seeds, which is, or Monsanto, either one, when they sell you seeds, they sell you a guaranteed germination rate. Maybe 85%, maybe 96%, depending on what you buy and what you're willing to pay for. But a typical customer has a team of 4 people whose job it is to walk around and look at little trays a little bit bigger than your laptop and count how many plants popped up from those seeds. 4 full-time people with clipboards counting plants. Well, we turn that into a query. Growing, same thing there. We're providing the full set of tools to the grower's dashboard, and you'll enjoy this. We are not an AR company, because if we said we were an AR company, greenhouse operators would not talk to us. What we do is provide you a live view with data overlay. Because that is something a grower understands. And I'm having a little fun with this because I spend a lot of time walking between the two worlds. And normally if I say something like AR, heaven forbid I say something like semantic segmentation in front of a customer, the sales guys are kicking me under the table. We have to say, oh, no, we recognize an object. We know what that is. But turning that, our language, into their language is actually a big part of adoption. And I think that's an industry-wide thing. We're out there on the edge. We're thinking about new things. We're making up new words. We have to, because we're thinking about new things. But that actually makes communicating with the end user, the customer, difficult. We have to roll it back. And I can tell another story. So 3 years ago, we were doing our first field trials in a greenhouse. I'm trying to take we've been working on in the lab into a greenhouse and make it work at scale in a real environment. And truth be told, we're mainly fighting Wi-Fi, trying to get lots of data out of a greenhouse that's way over there. That was the problem of the day. These growers came to me and said, we need your help. We lost this crop over in this other greenhouse. I'm like, hey, I'm an aerospace engineer, turned computer nerd. The reason I built this is I don't know anything about growing plants. Can't help you. But wait, they're the customer. What can I do? And they said, no, you don't understand. We lost them. We don't know where they are, and you have cameras. We want your help. Like, oh, I'm trying to make millimeter per hour growth rate measurement work in the field. What you want to know is where it is? Oh, inventory tracking. Inventory tracking is massive to them. They do not know where their inventory is. Now, this sounds funny. While I was working for Boeing, for 2 weeks, Boeing lost the left wing of a 747. That sounds hard to do, but if you're Boeing, they do a lot of hard things. Right? Well, what had happened is somebody had picked up and moved 2,000 plants. Well, they have 542 greenhouses. They just didn't know where somebody had put it. It's not actually that uncommon. It happens about once a month. And it's not nefarious or actually a big deal, but now somebody's got to go spend hours walking through 500 greenhouses to find out where did that lot of plants go. Well, solving that problem turned out to be the thing that completely changes their attitude, completely gets through any, that gets their interest. They're like, look, measuring growth rate, that's kind of spooky. That's hard to understand. Telling me where my stuff is, they get that. They understand it. So, produce. We are also in produce. Those are physically very similar. From the technology side, completely similar. A flower is a flower, a plant is a plant, the size is a size, but we have to do things very differently for food. Thanks to Chipotle, the rules changed. Before 2 years ago, if you were growing food in a greenhouse, you were not under FDA rules whatsoever. Chipotle's event changed that. There are now new rules. And this is where the joke turns around. Being Big Brother for food, everybody's in favor of. I don't know if you guys saw the news just a month or so ago. There was a big listeria outbreak. 8 people died. They were not able to find out where that came from. There was no way to go back and figure that out. The FDA's new rules, the brand new rules, say that if you're growing food and they hit you with a data recall, not recalling your food, but they want your data, you have 24 hours to produce a full record of the grow. What do they mean by a full record of the grow? They mean the logbook that someone has written down once a day, the temperature and humidity. That's the level of data that the FDA has to figure out what's killing people. And that's not okay. We can fix that. We can give them a full record that's a video. We can give them a full record that's a complete health analysis that says, here's where that infection started. Here's who to actually hit with a food recall. Because right now, it's medicine, it's triage. If they don't know, they will hit the grower with a food recall and destroy everything, because they have to. So the grower is actually very interested in this, because if you've ever met any growers, they're really good at what they do, and they never make mistakes. So from their point of view, they just want the data to show the FDA it wasn't me. Wasn't me, it was not me, here's the data. So they're big into adoption of this. The FDA is, of course, very interested in this as well, because they want to be able to save people's lives. Brings me to the one everybody always wants to talk about, cannabis. We are in Seattle, we are in California. We do have a number of cannabis customers. Regulatory-wise, though, they are generally related to regulatory-wise, they are restricted to fairly small size operations. But technology-wise, same thing. They have young plants. They want to count the germination rate. They have their own local species that we've had to train on. But a flower is a flower, a bud is a bud, a fruit is a fruit from the technology's point of view. Things we are working on. Bigger floriculture. These are the big guys. These guys doing multi-million square feet. Things are different at that level economically. We have to change up how we collect the data. And that is our new drone program, indoor autonomous drones, to augment what the mobile camera does to cover much, much larger areas. And then a fairly interesting new development. So if you are growing rose bushes or petunias and you are going to take those to market, you think of that market, that garden center at the retail center, as Greenhouse Z. It's just the 5th or 6th greenhouse that plant had to go through. It still has to be watered, it still has to be cared for, it still has to have good light, good temperature, until you walk in the store and buy it. So our customers brought us into the 2 big box retailers that I'm not allowed to name yet, to say, look, let's instrument these 15 to 20,000 square foot spaces as greenhouses. What came out of that was then, of course, the question of, hey, can you tell me how long somebody stands in front of that display? Can you tell me where you know all the questions that they asked then. But that's what we're working on right now. Jeff asked me to talk a bit about the technical challenges we've overcome and then go into the technical challenges we're still ahead of us that I would very much like you to solve for me. First one was positioning. The mobile, we call him Bob. the mobile camera. We tried really hard for some marketing names. Originally it was Project Thingamabob before we knew what it was, and Bob stuck. The customer loves it, customer's right. So here's Bob. But Bob has to get within 1 millimeter to get on that wireless charging station. And that turns out to be a little bit more difficult than even we thought it would be, even on a rail. So we ended up with a sensor fusion, if you will, but it's really just a set of reinforcing sensors. We've got a mechanical encoder on board, a beam brake sensor, so we actually have a, if you will, a very primitive Morse code style language of holes that are in the rail itself, an optical flow and slam system based on the camera, as well as an onboard IMU. And all of those things are really there to handle the gross positioning of, all right, where are you in the facility, which rail are you on, and then get down to a fine position to less than a millimeter precision to be able to get back on that charger. We do go with some brute force there. If it goes and hits the RFID that tells it what section of rail it's on, it then knows to go a certain distance to get to the charging station. If that doesn't work, reset. Try again. Welcome to mechanical engineering. It's not completely precise and repeatable every time. Also, commercial viability here. So when we first started, the idea was we'd put one rail up and put one camera and move back and forth, back and forth. Well, that actually works fine, but it's not scalable. When you start talking about millions of square feet, we have to get more coverage. And so we had to invent the railway system. First of all, this turns out to be a huge, huge recruiting advantage. Engineers love trains. And they're playing with an AI robot train running around on the roof. It's great. So we built the transfer station, which is exactly what it sounds like. It's an X, it rotates, it moves, lets them connect. Well, I don't have a picture of it here, but we also have a curved track that if you put down at the end of a 200-foot greenhouse, lets it connect, and then we build serpentine. So logically linear system, but it lets it cover a whole lot longer area. And that's a big deal. The more area we can cover, the lower the price can be. This is a slightly older model enclosure, but it was a really good picture. We had a fun one. So we knew we were going to be in a greenhouse. We know that water in greenhouses, it rains in greenhouses. Plants get wet. We built for, I forget the IP number, but you can take a shower with it. It's great, it's fine. We found out about 6-7 weeks ago at a customer in Toronto, they had a large amount of snow. Well, once you get about 8 or 10 feet of snow on top of the greenhouse, you have to open the roof, let the snow in, or it'll collapse. Well, 8 or 10 feet of snow, being under 8 or 10 feet of snow, is basically being submerged. We didn't build for that. So we had some losses, we took some damage, and so this is the thing we're now having to go back and revisit of, we have to actually be a whole lot more water resistant than we originally thought. Or we have to have some acceptable losses in the northern latitudes when there's more than 10 feet of snow. But we are now going back and re-engineering, looking at, could we go to a fully sealed enclosure? Problems with motors and computers inside of sealed enclosures. What else can we do to take those components up a notch in terms of water resistance? Because again, welcome to commercial engineering. Nothing's perfect. We're never going to make a camera system, a Bob, that can survive everything. But what can we do to take its odds up? This is something we're very much looking at. In the 3D sensing world, we are doing 3D sensing, but we've got a number of challenges there. First of all, highly variable lighting situation in a greenhouse. You've got greenhouse lighting, you've got sun lighting, you've got weather. It's never standard. Variable range. Some of our customers in a setting, we're 18 feet up on the roof above the top of the plants. In some others, we are 12 inches from the top of the plants. Noisy IR. Those lights put out a lot of IR and really mess with IR time of flight sensors. And we really have not found in the size and weight category anything that can really give us a good 3D model of a plant. Leaves and very complicated, intricate structures are kind of beyond the pale in terms of commercially viable sensors. Obviously, we can get some really expensive stuff that'll do it, but we're looking for something that we can deploy. So we need a smaller, lighter, more accurate, short-range 3D sensor, as well as kind of is one that is, well, just generally more ubiquitous. Then a fairly simple one to talk about, but turns out to not be that simple to solve. For what is known as row farming or vine crops. Which is very similar for grapes, is all of the fruit is down at the bottom. We've got to get the camera down at the bottom looking up. And that means it's going to get wet, it's going to get dripped on, it's going to get dirty. And so we're looking at systems that let us either automate the cleaning of it or make the cleaning not necessary. Now, this is an industrial application, and in between crops, they do come in, take everything down and clean it, and they're completely okay with, okay, well, we also need to, after we spray the soap, we need to wipe off the lenses. That's great, but it cannot be something that requires manual cleaning every day. We have to get to a system that self-cleaning windshield wipers. We've been looking at in the boating industry. There are basically protective clear sphere plastic balls that go around it, and then after each image they rotate, and it's got a little squeegee on the side, and it just keeps. Lots of things we're looking at there, but this is something that this audience, I think, is primed to talk about, is weather resistant, real world resistant imaging systems that can handle getting dirty and clean themselves. That's a big one on us.